Okay, guys, we're going to do just a couple of examples of the Boolean algebra. Let's take a quick example here where we're going to have this. So the first thing that a lot of times we're going to do is start doing some distributions. So we're still going to have the A and B and distribute this through. And I'm going to keep like terms next to each other. Right, so the BC and B, BC and C distribute down into this. Now, B and B is pretty clearly going to go away, right? Because if you have either of them, it doesn't matter if, more specifically, if you have a B on one, it's also a 1, meaning the only thing that matters is C. So this simplifies down to B and C. We don't need the extra B. Similarly, B and C. So we have B and C or B and C, right? Because this canceled and that canceled. Now, or of these, if we're thinking in gates real quick, or of the same two inputs, well, it doesn't really matter. We can just drop this one. So then, A and B or B and C, right? So distribute, reduce, there. Like terms on the B can be factored back out. So that's often where you'll end back up, is start factoring out, and we now have B and A or C. So there's our first quick simple example of Boolean algebra. Now I'm going to go ahead and show you guys another one . A or B and A or C, or A and C, right? Go ahead and pause this and start working through it, and then I'm going to start right now, but you guys can pause the video. It's good to do practice on your own. So if we bring down the A, or AB or BC, right? I'm just distributing like I said I usually start with. Then we can start looking at some of these like terms, which then we can say if I have A or A and B, right? Looking at that. Well, if A is true in this one, or A and B, well, this is a simpler definition of that, really. So this whole section of it can just go away. Simplify down to A. Because I can't have A and B without just A. And since this is or, it goes away. Now we can start looking over on this side of things, where we're going to just bring those down to a new line for simplicity. Right? Now we have this BC or AC, and this term you'll notice is AC. Well, we have that same situation, right, where you can't have A and C without having A, so now we're just at A or BC. So now there's that just simple rule. Or if it's A or A and something, you can cancel it out. Example 3, this one's a little bit longer, so I'll give you guys a new page, give you the function. It's going to take a little bit, make sure I don't do this wrong. Okay, right, so you got these big parentheses all ended with C. A, B not, C, or B and D, or not A, not B. Now, the thing that we often do is, right, we start factoring. And that gets a little bit interesting, but we can do it. So the first term, A, B not, C, or A, B not, B, D. Right, that's just this distribution through. So we still have this or, A naught, B naught, and all of this is still ANDed with C. Now, there's an interesting term here. We have B naught and B. We know that cannot be true, right? Because if one is true, the other is not. So that term goes away, which is really nice. So then we're going to bring this all down to A, B naught, C, or A naught, B naught, all ANDed with C. So here we can distribute the C through, because that's going to help us see this. Double C's, right? We just don't need that one. So now we have A, B bar. Sorry, I'm changing notation, right? You can either say B bar or not B or B not. They're all equivalent. So I just have these two terms that is A, not B, C, not A, not B, C. Now this one we can start looking at. We have this not B, C term with A or not A. Well, A or not A is always true, right? Because one or the others are true. It's inverted of the and you can just end up with not B, C. So that's a nice big fat simplification, and a few tricks along the way. Let's step it up and do an even more complicated one now. Here we go. So you'll notice this is, sorry, I have a hard time writing and talking, a format that we'll get from the truth tables. 1, 2, 3, 4, 5. Where you're getting a sum of a bunch of products. Now, I've got to go in and put the knots in there. Okay. So, don't stop the video yet. You're going to stop this and start doing it, but I want to give you the first step because this one can be a little bit daunting of where to start. It shouldn't matter very much where you start because you should get to, if not the same simplified form, a very similar one. But most of the time you'll end up with the same simplified form. So if I identify two terms that have some similarities, right? This has a BC, that has a BC, this has a not A, that has an A. Those are very similar. So I can bring those two down and just notice that I have BC, because I'm going to pull those out, and A or not A, right? Which that just cancels down to BC. So that is really nice, and now I can bring everything down with it. A bar, B bar, C bar, or we use that guy, have the BC, so let's bring this guy down. A, B, C, that's this guy and that guy. And I've used that one here, so then we have or A, B bar, C. Right? We're already down to 4 terms from 5. Makes the circuit a lot easier. So I would go ahead, this is for the C. Pause the video now, see if you can work through it, and then come back and I'll finish walking through how you're supposed to, well, one way to do this. Okay, so let's look at some other terms that I have that are fairly similar. So I have a nice C here, or sorry, not C and a C. And the nice thing is A, B naught, A, B naught. So let's do the same trick. Times C or not C. Boom, that goes away, simplifies down. Now we just have this. Sorry, we cancel out this one and we cancel out this one. So we have, let's see, that one, or A, B bar, or B, C. Okay, that makes sense for everyone? Now we're going to start looking at some other tricks. Where we can, let's see, what's a good one? This guy and that guy is an interesting one. Because they both have a, actually let's not use that one. Let's use this one. Because he has a B bar. So at least A, B bar, we have the C going on. Let's just pull out the B bar. Okay, so it doesn't directly see why that was important, but you can start feeling like, well, I have a not A over here and an A over here. That feels like it should do something, right? Because they're on the sides of the OR. And you can, but it's a little bit trickier than what we might like from the other one. So let's call it this rule, where if you have A or not A, B is equivalent to A or B. So this is a nice handy rule. You go ahead and prove this by exhaustion, which is just draw out the truth table and make sure that they're the same truth tables. But I have here, this term looks the same. So if we assign A bar B, right? That's the same. But B is really C bar. And then A or. So then B is C bar. We can have A or C bar or BC. Well, that's nice. So what happens if we distribute and look at this? And it can be kind of awful doing this back and forth, distributing and undistributing, but it ends up being helpful because you can start seeing some other similar patterns. Now we have kind of an interesting issue that would be nice to simplify, where you have BC or not B, not C. And it feels like that should be the simplify down. I don't see an obvious way to do that. The B bar. I don't know. We'll leave it here. This is a pretty good simplification that showed you this trick is the one to focus on. That's a good rule to remember. Okay, example number 5. This one is a nice quick one that you can use to see how rough things can get if you go about it wrong. But you would still get the right answer. It just makes it a little bit difficult. Pause the video, try and do this one yourself, and see how it works out. Okay, so the first thing that you could do, because I keep saying I like to start with distribution, is you could start foiling this out, right? Firsts, outside, inside, lasts. That would end up with a bit of a nightmare, and that might be your temptation. But make sure you look at all your options, because we have this guy here, right? A or not A, it's just always 1, which means that this is equivalent to, right? I mean, it's straight pretty straightforward. And then once you have that factor out the a, b, that is just always 1, or c bar. Well, 1 or c bar is just 1 a, b. Nice and quick. You can see if you foiled this through, you would actually end up with the right answer. But you'd be going from this to, 4 terms, and it would get pretty messy. So yeah, those are the examples that I wanted to go over just for some clues on the homework.